how do we graph these? Well, we're going to give our equation, and then we're going to find the intercepts. And our intercepts, remember, are going to be when x is equal to p and x is equal to q. Pay close attention here, because this is automatically negative according to our equation. So since it's negative in here, whatever we plug in is going to flip its sign. So if it's minus p, our intercept is going to be at plus p. If it's minus q, it's going to be at plus q. Now if this was a positive, so if we added something, here I'll do it in a different color. We're going to want the opposite of this. So it's going to be minus a negative p, so our intercept is going to be at negative p. And using these intercepts, we'll be able to find the axis of symmetry, because remember that a parabola is symmetric, which means that it looks the same on both sides. And it's symmetric about this axis called our axis of symmetry, which means that every point on the graph, say a point here and a point here, is going to be equidistant or equal distance from the line of symmetry. And the way that we can find the line of symmetry using a little bit of math is to take our larger number, our larger intercept, q. That's just why we're going to go in like alphabetical order, so our smallest is p, biggest is q. So we're going to go our largest intercept minus our smallest intercept and divide it by 2. We're finding the distance between these 2 points. We divide it by 2 because we say that this has to be like equidistant from each other. And that distance that we get out from here is actually going to be the distance from our intercept to this line. So this distance is going to be the same as this distance, which is given with this. You take, one last time, you take the difference between the 2 points and divide it by 2. Now we're going to find our vertex. Now remember, our vertex is going to be living on the line of symmetry. And the number that we just pulled out is how far away our intercept is from the vertex. So if we do our intercept, q plus q minus p over 2, that will give us our x value of this axis of symmetry. We're going to plug in some easy points, and when I say easy points, I mean things that are going to make your life easier, like 1s and 0s and 2s, things that you don't have to deal with, and you're not multiplying really big numbers. And you're going to draw the shape because it's going to be the same exact shape as it was before. Let's practice a graph here. So if f of x is equal to x minus 2 times x plus 3, remember f of x is equal to a times x minus 2 times x plus 3. You may think, oh, there's not an a here, but there is. There's always the 1 that's hanging out there in front, and notice that's a positive 1, which means that we're going to be looking we're going to be looking at a graph that looks like this. It's going to be concave up. So let's find our intercepts. We remember that they're the opposite of what we have in the parentheses. So since we have x minus 2, one of our intercepts is going to be at when x is equal to 2. We have x plus 3, so one of our other intercept is going to be at x minus 3. So those are our 2 intercepts. Now where is our line of symmetry? Well, we can like do it this way, and oh crap, we're going to be somewhere in the middle between here. That's unfortunate, but it's doable. The other way that we could do that is we could say, okay, so what's the distance between the 2 points? Well, the different distance between the 2 points is going to be our most positive minus our most negative, or our least positive. So since we have 2 minus 3, we're going to end up with 2 plus 3, and we're going to divide that by 2. So we actually end up with 2.5. So this is the distance from the intercept. So we have negative 3 plus 2.5 is going to be where our axis is. We can check it. We can go 1, 2, 2.5. That's right. Here it's going to be 2 minus 2.5, so 1, 2.5. We're on this line. So indeed, our line of symmetry is actually on negative 0.5. And if you plug that in and chug it out, and I'll let you do that, you'll get at negative 6.25. So somewhere down there. Let's plug in 0, because 0 is a nice easy point, but it doesn't really help us that much because it's at negative 6. And remember, since you can flip across the axis of symmetry, you can double it on the other side. And since that didn't really work out very well, let's plug in 1 for x, and here we'll get out -4. Now here's the really nice easy thing about these. You plug in 1, so you have 1 minus 2 times 1 plus 3. So much easier. Now if you want to check and make sure you're doing it right, you can go back to standard form, and you would do that by foiling. And remember, it's this fun thing where it'd be x squared plus 3x minus 2x minus 6. And then you'd have to make it nice and simplified, plus x minus 6. So that's this same equation in standard form. This is going to be so much easier that you're never going to want to go back to here. And then once you have your points, you can draw in your graph as nicely as you can, and that's it. Now we're going to do it again. Remember, we're going to take the opposite of these two numbers, so the opposite of -7 is 7, the opposite of -5 is 5. Draw our axis of symmetry. Here, let me do it in this color. I like that one better. And conveniently, the distance between them is 2, so we're going to be 1 away. That makes our lives easier, so we can plug in 6 for our x. If you wanted to check this, by the way, it'd be 7 minus 5 over 2, which is equal to 1. So you'd be 1 away from 5, which is at 6, or 1 away from 7, which is at 6. If you plug in 1, you're going to get out -2. So you're going to go down to -2 and put a point there. Now, I'm going to plug in 4 and make a guess based off of my pattern knowing. And if this is right, let me know. Making a guess based off of my pattern knowing, it's going to be at a +6. Remember that we're opening upwards, so because of this +2, and it's going to be skinnier because it's it's going up faster than normal. So we're going to end up with this as our graph. Now here's a quick check. Before you run into this, I want to let you know that here's like a cheating way of doing this. This is the same thing as y minus 0 times, y is equal to x minus 0 times x plus 3. You can FOIL it out if you want to, FOIL both of these and see what happens, but just believe me that it's the same thing. So go ahead and graph them. Once you've done that, you can go ahead and check them in Desmos, and after that, that's the end of this lesson for today.